All right then. So good evening, everyone. Good evening once again. Um, so today's session, it's actually a repeat. We had this last week Monday as well, but I noticed that more people are still having issues with the project, with the integrated project. So this particular session is just to let us know that we are not alone, and you know. So today we'll be going through everything slowly, and we'll try to break the project as simple as possible. My name is Ali Olatunde. You can call me JB. I'm currently part of the your cohort. I applied for data science, and this session itself is part of my own learning journey. So I'm doing this teaching just so I can, understand more. So our goal today basically is to understand what the integrated project is. So without wasting much time, let's just dive straight into it. All right. So this is the integrated project that we had for the second week, the part one. So the integrated project, access to drinking water, understanding the data. Um, so this project itself is into two phases. So last week was we understanding the data, and this week's project, um, which the deadline is on Wednesday, would be us transforming the data. So the understanding the data part. So this is the overview, and basically, so first thing we'll be doing will be getting familiar with the data sets. Then we would import the data set, and then we would investigate the data set. From investigation, we would investigate the access by area. We investigate access by population size, and then we would investigate access by income group. Think to get clearer when we go to the next slide. All right. So the data set we are actually looking at is from the WHO UNICEF GNP. So this is a data set that has been done before by the WHO UNICEF. So it's an estimate of the use of water for the year of 2020. Now, these are the features of the data. The data has, once we go to the data set, you see clearly, but it has a name column, which includes country. I mean, we said it's the estimate of data use, right? So it has different countries, and it will be talking about different countries and relationship with water, right? It also has income group. So income group is more like classifying the country's income based off of, is this a low earning country? Is it a lower middle? Is it upper class? Is it higher class? Stuff like that. So and then we have the pop n. So pop n is the national population size. So it's the population of each of those countries and is in thousands. Take note, thousands. Now we have PopU. So PopU is the urban population. So from the data side, we can deduce that okay, Pop N is the national, Pop U is the urban. We should also have a Pop R, which is the rural. So Pop U is the percentage population of people living in the urban area of that country. Now we also have Watt base N, Watt lim N, Watt on N, and Watt SURN. So these four different levels, right? These four different levels just showing us the national service level. So the Watt base N is simply the percentage of people in the nation that has access to basic water service. And then the Watt limit N is people in the nation that has access to limited service. And then the Watt on in pen is percentage of people using, unimproved sources, while the what SURN is percentage of people relying on surface water, like streams, river, thereabout. So now we have this Watts base. We have it for nation, we have it for that's national, we have it for rural, and then we have it for urban. So nation has Watts base N, rural has Watts base R. So rural will be the percentage of people, you know, in the rural space with access to basic service of water. So, and then there's Watt lim R, there's Watt on in R. So basically all these features all together. So we have about a total of 16 features or columns in our data set, and 12 of which are service level percentages. So from our data set, so the question they're asking now below here, they're saying, which data type do we expect to for different features in the data set? So from what we can see here, we can expect that name being national is a categorical data. It's a categorical data. Income group also should be a categorical data, like I explained earlier on. It's lower income class, middle income class, high income class. And then we have pop n. So pop n is in thousands, and that should be an integer. And then we have pop u, which is in percentage. All the other ones are in percentage. So percentage would be a floating type, a floating data type. So basically, we have three different data types in this, or we are expecting to see three different data types in this particular project. So the first one will be the categorical data, which is name, income group, from what I said, which is low income, high income, which is a categorical data type. We also have integer, which is pop n, and all these other ones are floating data type. Let's move. So the next thing we'll be doing, which is the number 2, is now that we understand our data, the next step would be to import our data, right? So how do we import the data? So we'll make sure that we have access to Google account, because we'll be using the Google Sheet. And we'll create a new blank spreadsheet with Google Sheets. So, we've already downloaded our data set, which is a CSV file. We'll import our data set into a blank spreadsheet. So below, it shows us how to import the data. So when importing data, we can either assume that the values are comma separated. So there are different types of file formats in spreadsheets. So there's the comma separated file format, there's the tab separated file format. So the comma separated is what just makes it different is basically as a result of the delimiter. So delimiter is more like, is it separated with a comma? Is it separated with a semicolon? Is it separated with tab or space or pipe? Pipe is like a straight line. So whatever it is separated with, we would have to take note of it while we are importing our data. So what does it say? So the first thing it said is that we'll see that even if we set the separator option as default automatically, the column headers are not separated because semicolon were used as separators rather than commas as in the rest of the data set. So this says we now also need to check for other instances of semicolon separators to ensure that values are not misinterpreted later. So the C says we'll use data and then split text to column in our toolbar to split the column header into appropriate columns. So we know that we have 16 features. We've seen that earlier on. So we need to check that each of those columns, A to P, has a column name, and we have 16 columns. So it also says that once we are done imputing it or importing it, we'll use Control F to search for other instances of semicolon and use the same method to split it. So they're saying we should find 5 occurrences in the data row in different rows across the sheet. So we should find 5 occurrences that also have issues. So let's just move straight to our data type and our data set and then impute. How to get to spreadsheet. So this is spreadsheet. This is my Gmail. I could easily just come here, click on this Google app icon, and then click on spreadsheet. So for me now, I had already downloaded, the data set initially. So I could just click here, or I could just go to blank sheets like they told us to do and click on, then I click on file on the menu bar, and then I click on import. So now, like I said, I had already downloaded it before. So all I'll be doing is upload. So once I click on upload, I'll click on browse, and then I can see this here. So I'll click on open. So it's saying, should he replace the spreadsheets or insert niche or creating? Let's just replace the spreadsheet since we've not used it before. So we import our data. All right. So apologies for this. So now that we've imported our data, earlier on we said we ought to see 16 columns, but you can see clearly here that the columns are not properly defined. We can't see them. Though this ones under here, they are actually rows and column, they are clear. But this first one here is not clear. So what would, just to make you see it more, you could just open it this way and see that it seems that that first column is housing all of the data. Yeah, so we need to separate this first column because every other one here seems to be fine. Now, if you look at those, if you look into the formula bar, you could see that it's separated with a semicolon. So how do we do that? How do we split our text to column? So we'll go to data on our menu bar. We would look for this split text to column. Please take notes. From the get-go, I clicked on just this one because this is the only one that is affected to my eyes currently. This is the only one I can see that is affected. All these data you're seeing here are actually inside this cell here. So I'm clicking on this cell. So I'll come to the menu bar, click on data, split text to column, click on that, and then separator. We can see that it's a semicolon, so we separate using a semicolon. So now that we've done that, we can clearly see our columns. Just to make it a little bit clearer, let's just bolden it and increase the size. Okay. So we can clearly see our data set now. And like they said earlier on, when you look at column A, which is name, you can see that it's name of different countries: Cook Islands, San Marino, Monaco, Greenland. So these are names of different countries around the world. And then if you look at this income group, you can see that it has NAN, it has high income, it has upper middle income, it has high income, upper middle income. All right. Now, this one earlier on, they told us that this is the population of each country. So, Nui, for example, so this is the population of population of people in Nui, but in thousands. So it's not the actual, they made it in thousands. Now you can see Popu. So Popu now, this is the percentage. So this is the percentage of urban people living in Nui. So 46% of this, national population of Nui is is the population of the urban. Now they now also, give us the percentage, of different water service, the basic, the limited, the unimproved, and the surface. This is for nation, and then for rural. And if we go to the side, we'll see for urban. So now that we've been able to separate it this way now, um, I mean, the data is looking more like a data set. But he told us to do something. We go back to, he told us that we should use Control F to search for any other instances of the semicolon. Um, sorry. All right. So I'll click on Control F and I'll search for colon. So you can see we have 1 of 5. Looking at this one here, highlighted in green. If I expand it, you can see that there's another data inside here. So it wasn't separated fully, it wasn't separated properly. Let's go to another one. Yeah, you can see it wasn't separated fully. This one here as well. If I move it to the side, or this one here, if I move it to the side, you see a semicolon, it wasn't also separated fully. So what did they say we should do? So now we found the 5 occurrences that they spoke about. So what did they say we should do? So they are telling us now that we know that we have 16 features. So we need 16 cells in each rows. And we also see that missing values are represented as none in our. So it means that in every of the rows we are having, every of the rows there must be something there, and we must see 16 rows, right? If we don't have any data set, we should see a none at least. So if we are not seeing anything there, if it's just a blank space, then something is wrong. So what they want us to do is they want us to count the numbers of value, both numbers and text, and apply a filter. Okay. So we'll count it to apply a filter. So what did they say we should do? They said, let's create a new feature called value count. That counts the number of cells in each row that has a value. So it's going to count both numbers or text, anything that has a value in each row. So it should, regardless of whether the value is a text or number. So we use the count A function. All right. So they're asking us what would happen if we use function count rather than the count A. So let's go back to our data set. So this is our data set. We had to create. Okay, before going too far, I think we need to freeze our first row. So how do you freeze? Freezing, you'd okay. So how do you freeze? You'd come here, you click on all the things you want, the row you want to freeze. So we want to freeze row 1. So we'll come to view, we'll come to freeze. So we're freezing just 1 row. So now that we freeze, it means every time we come down, we go up, we'll still be seeing our column names here, so we don't get lost. All right, so we're told to create a new column called value count. Control V. So we have to create a new column called value count. I'm holding it as well. So what will be in value count? So value count is going to count the numbers of rows here, right? So not just, so including the ones with text and the ones with numbers. So how do we do that? So to start with, equals to, we write the count function. So as we don't even have to do too much, as we're writing the count, we can, we would see Google is going to bring out the functions for us. So we're told to use count A. So we click on count A. And if you click on these 3 formula menu here, okay, if you click on this drop down button, you'll be able to expand and see what count A is about. So we don't necessarily have to cram each of those formulas. So count A now, you can see that count A, for example, it's saying um, for our column A, it will count out, for example, now it returns the number of values in a data set. So we've written the count A. All we just have to do is left click and drag to the side. So which is the range, and then we click on enter. So you can see that we have 16, like, the data set initially said that we ought to find 16 rows and 16 columns. So, so if I click on the mark here, it would auto fill downwards. And if I don't want to do that as well, I could just come here, wait for this, and then click on that circle and wait till I see a cross sign, and then I drag it down to the end. So once I do that, it would, copy all the formulas as well, and it will act on the rest as well, fill in the rest similarly. All right, so we've done that. Now, so we are seeing 16. They told us we should now use filter. So filter is basically.
Sorry, Mr. Olatunde. Sorry
Yes,
to
kind.
cut. Sorry,
Okay.
I'm a bit lost. Sorry, that's second thing we have to do because my data is actually on. The ones that have semicolon, how do we remove them? I know they said we should use Control F. Sorry to bring it
We
back.
we are we are we are getting there. So you're not
Okay.
referring to the initial data, right? The one we separated our
The, the ones that have, they said we should look at five.
remaining 5 occurrences. Yes,
Yes,
we're
I
getting
have
there.
to remove that.
Yes, we're getting there.
All right.
So
No problem.
we'll be following this is the guide here. So we'll be following it step by step. So we don't have to, miss any step. So this is what they told us to do now. We've done the value count. So value count counts all the rows, and they told us to filter. So how do we filter? So click on this particular section here, right? Once I click on the section, it selects all the spreadsheets, right? And then I come to this toolbar here and click on create a filter, or I think it's in data. Yes, data on the menu bar, and click on create a filter. So once I create a filter, I could easily just come here, drop down, and then I can see, the columns, like, sorry, the each individual rows, this column value counts. What are the um, what are the rows there? Like, what are the values in each of those rows? So we can see that we have 15 and then we have 16. And with what we did was a value count. We ought to see 16 general. So it means the ones that have 15, they have 1 or 2 missing, right? Which is the same reason why when we did our column, find our column, we saw that there were some cells that they still had 2, but there were cells that still had 2 values inside of that cell. So we have to separate. So now what we'll do is we'll come to this clear, and then we'll tick on only 15 so that we can see the rows that is not complete. So click on OK. Yes, so you can count that about five as that issue that is not complete. I mean, just by looking at this 5, you can see that this what SURU for urban, there's no value for it. So it's definitely because its value is already inside something. For example, see it here. See this one now. If we move it to this side, you know. So yes, now that we've counted that we've seen our 15, let's see what our guide says. So our guide says that what will happen if we use the function count rather than the count A. So count A, the reason why we're using count A is because we want to count both text and numbers, right? And because you can see from our data set, it's not just numbers. If we had used count, it would have counted only numbers. You can see that upper middle income is a text, Tonga is a text. So we needed to count both text and numbers. That's the reason why we used count A. If you had used only count, it would have counted only the numbers. You most likely have seen 13 there. All right. So you said we should add filter. We've done that. Create a filter option in the toolbar, or by right clicking on the column header, unselect 16 like I did earlier on, and then the value would we expect from the filter to only observe the rows that's imported incorrectly. Now, so to fix the 5 rows by moving the cells after the cell with the semicolon occurrence to the correct cell. So we are going to use the data split text to column again, like we did initially. So we'll remove the filter. Once we're done removing the filter, we'll check. Okay, once we've used the split text to column, to adjust it, we'll remove the filter and then we'll check the value count again to see if everything now equals to 16. So let's go back to our data set. So our data set would use the control F again, just so we can find the in this one the ones that are right. So now we can see them. So this is the first one here. So what we need to do is we need to move all of this to the side so that we can create a different space. We can create a different column where we can, split this one into. Because if we split it now, what will happen is that this 59.194 here would override this 77.79, and then we've destroyed our data that way. So we need to first create a space. So this is what we'll do. We'll come here. So we'll, insert cell and shift right. Right. So we are creating a space here. So we've shifted it to the right, creating a space so that we can split text into this column here. So we'll come back here. We'll go to our data menu, split text to column. And then the same thing we did earlier on. Our separator is going to be our semicolon. So we'll click on semicolon. Now it has imputed here. So let me just go to the side. If I go to the side, oh, so you can see that this what SURU has already been fixed. There's the data here now, right? But this our because we moved everything to the right, this our value count now is empty. So we would have to delete this particular cell. So once we delete the cell and we shift left, so it brings back um it brings back the data back to the value count. So we'll repeat that same process for the remaining 5. I hope it's clear. So Control F, we click on column. We've done the first one. Now we are on the second one. So the first thing we'd have to do is to shift all of the cells to the left so that we can, have space to impute the one that is here. So that's all. So right click, insert cells, shift cells to the right. So we shifted all the cells to the right. Now we'll come here and then we come to our data. We split text to column. And then our delimiter is semicolon. Okay. So when we go to the side, we can see that it has moved again. So we'll delete it. Okay. Let me just do this one here. So the first thing we'll do, to the right, don't mind this figure here. It's the figure from here that is extending towards that page. If I increase it this way, you see that it's a blank sheet, it's a blank cell. So the same thing will come here, click on data, split text to column, semicolon. Now it has moved to this place. We'll delete this one here. Okay, so we still have two more that has not changed. And that still has empty what SRU. So let's go to the second one. So this is it. We'll come click on this one here. We'll move it to the right. So we have empty space here. So click on this one again. Then we'll split it by column. So we split text. Oh, sorry. Data, split text. Oh, I'm not clicking. Data, split text, semicolon. All right, so we have one more. The same thing. Come back here. Data, split text to column, semicolon. All right. So now we've been able to fix everything. We'd have to delete the cell. Delete the cell as well.
Sorry, Mr. Olatunde, can you hear me?
Yes, I can hear you.
Okay, this shifting to the right you're doing, does it automatically go to the right column it's supposed to be? Like once you just shift to the right, are we supposed to create an extra column, a new column first of all before shifting?
Yeah. So let me do Control Z so that you can see clearly. All right. Control F, column. Oh, I fixed it already. Control Z. Okay. So let's take this one for instance now. Control Z again. Let's take this one for instance now. This particular one that has green. If I move to the end, we would see that if I move to the end, we would see that this one here does not have any value. It does not have any value. And the reason why it does not have any value is because during the process of separating, you know, like all those texts, they were joined together with semicolon, right? And they were joined accordingly, right? So the data for name would, after the name, you'd see income group, you first see semicolon and then income group, then pop n semicolon again, pop u semicolon again. So it was joined like that, right? So during the process of separating this particular, this one, like this one here, for example, this pop u here did not separate fully. So it means the data after the semicolon here is supposed to be, is actually data for base n, not the 7.909 that you are seeing here. The 7.909 is as a result of this one not separating. That's why it is under what base n. So it's supposed to be under what limit n. And if it's that way, we would have a complete data set, meaning that even this our what SURU would have a value, not just a blank space there. So that's the reason why the first thing we have to do is we are creating another space. Before we create, sorry, the first thing we have to do is we are, you know, creating a space. While we are creating the space, we are moving all this to the right. We are moving all these ones like this. Let me show you. I hope it doesn't affect the data. So all these ones like this. Control Z. So we're moving all of this to the right so that this one here, so that 0 here would fill in for SURU, because that's how it's supposed to be. 0 here will fill in for this, this what base u would come to this place because that's where it's supposed to be, and what base u, what limit u, sorry, what base u will come to what limit u, and what sur so r will come to what base u because that's how it's supposed to be. So that's the reason why what we are doing first is we'll come here, would insert a separate cell, because if we go ahead and split the column this way, what would happen is this value here, this 88.76, would override this 7.904. It would delete this one and put the new value there. And our data set is not complete that way. So what we need to do is move all these ones to the right so that we can complete the last one there and create the space for this one, the actual value to be here. So that's what we're doing. So that's the reason why we are coming here. We'll click on, we'll right click, and then we insert cell and shift to the right. So we come here, and then we'll click on the data we want to separate or the cell we want to separate. Then we'll come to data on the menu bar, and then we'll split text to column. Our separator would be our semicolon. Sorry, I hope it's clear now.
Yeah, very, very clear. Thank you so much.
You're welcome. So this now would have to delete it. All right. So then what they told us to do now is that once we are done, we made everything 16. We'd have to remove the filter. So I'll remove the filter. Now we've gotten our data set back. So let's go back to our sheet to see other instructions. So now that we've done that, we've been able to, split everything. You can see what he said. He said data split text to column will override or overwrite the adjacent cell, which is the cell beside it, when it is applied to a single cell. However, if it's applied to we can also apply it to an entire column. The adjacent cell will automatically be shifted if you apply it to the entire column. I think I'll try this in another time. All right. So when we go to the next section of our understanding the data, so we are supposed to investigate the population size. So we have to investigate the population size. So we want to summarize the national population size to better understand how the data set represents the entire world population. Now, they now said in 2020, the world population was estimated to be 7.821 billion, and then 55% of which lived in the urban area. So now this is a different figure here. It's different from our data sets, right? The one we got from the World UNICEF GMP. So they are now telling us that using a different census, the world population was estimated to be 7.821 billion. And then 55% of that population is urban. So now what are the tags we're supposed to do here? So we are supposed to compare the world estimates, that's the world population, with the world population of our own data sets, with our data set population. That's one. And then the second thing we're supposed to do is, because we're trying to understand the data, the second thing we're supposed to do is we're supposed to now compare the urban population and then the rural population of our data sets. So we'll come down. Let's continue reading. So what does it say we should do? It says we should create a summary to compare the data set population to the estimated world population. So what are we going to create? So we'll create a new sheet, which we'll call the Global 2020 Report. Let me copy it. Okay. So in this new sheet, we'll determine the total national population size. So we want to know the total national population size of our data sets. Now, we already know that POP-N, which is the population of each individual nation. So to get the total, it means we'll have to add all of the population of each of those nations. Population for Monaco, population for Benin, population for Nigeria. We would add each of all those populations to get the total national population size of our data sets. Now, they also now said we should also add the estimated world population. They already told us the world population is 7.821. So in this our report, we would also put a section to say, okay, this is the world population estimator. Now, so they're now telling us to remember that pop n is in thousands. You know, when we were reading the features of each of those data, they told us that pop n is in thousands, and then the rest of the numerical data are in percentage. So in thousands is not an actual number, so we have to convert it to the actual number, right? So they now said, while the estimated world population is in billions, so this, you can see this is 7.81 billions. This is still not actual figure. So we have to convert these billions to actual figure, and then this pop n, which is the total, the pop n, which is in thousands, to actual, so that both of them would have the same SI units, the same units. Because if they don't have the same units, we can't work with it. We are giving false data. So they have to have the same unit because we are trying to compare the two. So in order for these values to be comparable, we would need to ensure that they are in the same units. All right. So we also want to compare the world urban population. That's, you know, they already told us that the world urban population is 55%. So it means 55% of the world population will be the world urban population. So we'll calculate for that. So the data sets urban population, we already have a percentage for the urban population of the urban for each of the nations. So we'll do that. So we also, let me just do this first one first. Let's do this one first. So he said we should come here. So to create a new sheet, additional sheet, letter still, or to add sheet to our spreadsheet, we'll come to this button here, the plus button. You can see it wrote add sheet. We'll click on it. And then this drop down menu here would rename it. The name is Global 20 Report. So we've done that. So what did he say we should do? So they told us to calculate the total population in our data set. So first thing is total underscore data set population. Let me see if other instructions were given. All right. So you can see here, they said determine the total national population size using the pop n. And then the estimated world population is 7 points. So let's just put the estimated world population beneath. So world population. World underscore pop. We're told the world population is 7.821 billions. Right. And then the total data set population, which is, let me go back to the data. So this is what they want us to do. This is pop n. This is the population of each of the nations. So for example, Greenland now, the population in Greenland is 56.77 in thousands, right? So what we are supposed to do now is they want to know all the population of all these countries, all of the countries here, because we're trying to compare our data sets, the one they give us, with the actual world population. So all these countries you're seeing, you know, Niger is here, Mali is here. So we want to know the population. So we would add all this together to get the total population. I mean, the total people population in our data set. But mind you, to be in thousand, that's what we'll do. So it will be is equals to, because we are trying to add, so we are using sum. So once we type SU, the remaining will come out. So you just click on the sum. Once you click on the sum, since our data is in the different sheets, so we don't have to do much. We just come here, click on it on the different sheets, and then we can either click on the column and it will pick all the values in column C relating to pop n. Obviously numerical values to pop n, and then it will do the sum to add each of everything here. Or you can just come here. I mean, you can just, so let's just click here and then we'll click on enter. Let me don't overcomplicate things. So this is it. So mind you, this is in thousands and this here is in billions. So we need to convert both of them to be in the same SI unit, normal one. So since they said it's in thousands, to convert this one to thousands, it means we'd have to multiply it by 1,000. And to convert this one to billions, it means we have to multiply it by 1 billion. So how do we do it? So we just come here, is equals to, click here, and then click on the cell, this cell here, and then we multiply, which is cell B2, and then we click on the multiplication, type the multiplication symbol, and then you type 1,000. So this is the actual, this here is the actual population of all the countries in our data sets. Now for the world population, we'll do the same thing too, is equals to, this is what we want to convert to cell B3. So we want to convert it to the actual number. So we'll multiply it by 1 billion, which is 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll click on enter. Oh, sorry, because it has billion here.
Okay.
Go ahead, please. What did you say?
No, that's ask. Okay, okay. It's going to be multiplied by by billions again, right?
Yes, you multiply this by billion to convert it to actual number. You multiply this one by 1,000 because it's in 1,000 to convert it to actual number. So now the two of them now they have the same SI units, right? So this has been settled. Now, just barely looking at it, you can see that our data set, the population in our data set and the population in the world population is quite close, right? So let's go back to what our value says we should do. So now that we've changed both of them to the same SI units, what would we do next? So we also want to compare the world urban population to our data set urban population. We need the total number of people living in urban area from our data sets, right? So we need all the people, the population, the total number of people living in the urban area in our data sets, which we can either compare as number or percentage to the world. So we can either compare the percentage, they told us it's 55%, or we compare number, which is we convert it to number and then we compare it to the world urban population value. So let's create a new feature on our data set and we'll call that feature PopUval, right? So PopUval will now be the number of people living in urban areas per country. So we'll use our feature PopN and PopU to determine this new feature. So what they are telling us is now that PopU, we said earlier on that PopU is in percentage. Percentage is not actual number. And you can see from here, they said we can actually compare our data set urban population in percentage or compare it in number or percentage. So if we are using percentage, it means our urban will be using the world 55% to compare the percentage of PopU in our data set. So, but if we are using the number, it means we would have to convert this PopU to number, because PopU is in percentage at the moment, to number. So, which is when we convert it to number after we've created our PopUval column. So PopUval would now include, the PopU converted to actual number. So how do we convert to number? They are now telling us that we are using this PopN and PopU to convert to know the actual number, the actual population of urban people in our data set, not in percentage, but actual numbers. So now they said, look here, they said, remember, Popu is in percentage number. There is a difference between percentage represented by a ratio versus a number. So we need to divide our percentage by 100 before we multiply. Let's see if there's more. So they said in our global 20 report sheet, let's determine the total urban population from our data set using this newly created. All right, so let's go and create our Popuval. So we'll come here. So we'll come here, we'll move to the end because we are creating a new column, and the column is Popuval. So I'll bolding it. Now we have Popuval. So they told us we are working with Pop N and Pop U to calculate our Popuval. So how will the calculation be? Now let's go to our Pop N to see, or our Pop U. So you can see here now, initially I told you that this is in percentage. So it means, this statement means 46% of our population, this Pop N, is urban. That's what this statement means. This number is telling us. This number here is telling us that 9.1 percentage of our total population here, right, is urban. So now we have to remove this from percentage. What we'll do is we'll divide it by 100, and then we'll times by the population N, which is the Pop N in thousands here, to get the Popu value in thousands. I hope that's clear. Hello?
I'm with you. I can hear you.
Okay, thank you. So what we'll be doing here is equal to, all right, thank you. So what we'll be
I'm
doing,
with you.
thank you.
Sorry, sir.
Thank you.
Sorry to be cutting. So I'm trying to follow, but the recording you're making, I hope we'll get it.
Yes, we'll
Okay.
get it. But at any given point, when you are not clear, you could just, draw me back, but just don't make sure we've gone too far. Try to make sure we've not gone too far when you're drawing me back. All right, so now Popuval. So we'll be using the Pop N and Popu to calculate our Popuval. So what would that be? So is equal to Popu. You come to the formula bar to continue typing your formula, divided by 100 because it's in percentage. 100. You close your brackets, and then you multiply by your Pop N, because like I said earlier on, Popu is a percentage of the Pop N. So you multiply by your Pop N to get your Popu actual value in thousands. So click on enter. You can see that this is 0. I mean, obviously to be 0 because our Popu, the population of our urban percentage was 0. So it means that particular country, they don't have urban at all, it's just rural. So we would autofill to do the remaining for us. You can see that this one, and when you autofill, you can see that it's no longer on the second row, it's on the third row, D3, divided by 100 times C3, which is the third row. So now we have all the values for Popuval. All right. So now that we have the value for Popuval, we've calculated the value for Popuval. That's in thousands, right? And they told us that they want to know, the total number of people living in our population. So the same thing we'll do. Now that we've gotten our value in thousands, we'll do the same thing we did earlier on. So the same thing we did earlier on, which is total urban. So let me just put U, which is urban. Total, okay, data sets underscore urban underscore population. So this is just saying the urban population of the total urban population of our data set. So same thing we did here. We're going to sum all of the POPU val to get the total actual value in thousands. So is equals to sum. So you click on the sum, you come to the sheet you want to use, and then you go to your POPU val column, which is the column R. You click here, and then it captures everything, and then you enter. So, like I said, this is in thousands. So we have to convert it to actual number. So converting it to actual number, it will be the same thing we did, multiplied by 1,000, because the z is in thousands. So we'll click here, then we'll multiply by 1,000. So this is the number of, urban population in our data set, the actual number. Now, they also told us to calculate for the world population, right? They told us to calculate for the world population. So that will be world underscore urban. So just you underscore population. So this is our world population.
Sorry, Mr. Olatunde. So this new sheet. Sorry,
I
sir.
can hear you. I can hear you.
Yeah.
Right.
This new sheet you created is called Global 2020 Report, right?
Yes, it is.
Okay.
All right. So the world UPOP is like, when we were reading it told us here that urban population, where is it again? They told us somewhere here that urban population is 55% of our data set. Why can't I? Okay, this is it. So they told us here that 7.821 billion is the estimated population of the world at 2020. They now said 65% of which lived in urban area. So they are telling us that the urban population of the world is 55% of our estimated population. So we come here. So world urban population, which is 55%, 55 percentage, right? So 55 percentage of what? So is equals to this here, which is the 55% times our actual world population, not the one in billions, or the one we've converted already to actual number. So we'll click it and then we'll click enter. So this is the world urban population. And as we noticed earlier on also, it's also quite close. Looking at the number, it looks like it's actually close to our data set. So our data set urban population is 43 billion. And then for our world population is also 43 billion, but just shy of difference of some thousands.
Sorry, excuse me.
Yes.
And I was thinking you do 55 divided by 100 times the total population, but you just went straight.
55 divided by 100 is also equals to 55%. The percentage itself means divided by 100. Do you understand?
Yeah. Okay.
So it's just, so now we've gotten the values, right? So let's go to our data set back and see what it says. Yes. So we've done that. So remember, POPU is a percentage number. There's a difference, and we've done that as well. So I just want to remind us again that what we are doing as of now, we are understanding we're investigating our data sets using populations. You know, we have a known population, and we don't know the population of our data set. So we're literally just comparing the known population, the estimates we already know, with the estimates in our data sets, just to find any information we can find. All right, so next thing says in our global 2020 report sheet, let's determine the total urban population from our data set using, we've done that. Why can't we calculate the total urban population from the original urban population feature? You know, we made mention that we can't use it because that is actually in percentage. It's not in thousand and it's not in actual number, so it's just in percentage. So we have to convert it to actual number, which we've done already. So he also says we know that the estimated world urban population in 2020 was 55% of the total population. So let's estimate how many people that will be in the world population of 7.821 billion in our. So we've done that also. We've done 55% of 7.821 billion. Now, we now said we know that the estimated world share is 55%. So let's calculate, we've done this. We see that our data sets, national and urban value, are in the same value order as the global estimates. Yes, so the global estimates we calculated and then our data set values are actually close. So now they're now asking us, how do we represent our findings in a more quantitative way? So we want to understand it more so that it can make sense. So what they now say we should do is let's calculate a percentage difference. So they're saying we should calculate a percentage. So a percentage difference to determine the difference between the number of people included in our data set and then the estimated number of people in the world. So how do we calculate? So let's also calculate. So we're calculating for the total number of people, and then we're calculating for the total number of urban population, right? But how do we calculate the percentage difference? That's what they wrote here. So percentage difference refers to the difference between, all this is English, relative magnitude of two values expressed as a percentage of the average of those values. You don't need to stress too much. This is the formula they want us to use. V2 minus V1 divided by average of V2 and V1. That's V2 plus V1 divided by 2 times 100. So where the V2 and V1 are the two values we are being compared. So what are we comparing? First value we are comparing the national total population in our data set, or the total population in our data set, and then the world population. And also we are comparing the world urban population and then our data set urban population. You understand? So we are doing two of these percentage difference. Now they're now clarifying again. They said this pipe symbol in the above equation, you can see this straight line here, pipe symbol, represents the absolute value, which is always a positive number or a zero. So we can use absolute function in the Google Sheet in the following ways. Absolute. So what does absolute do? What does absolute do? So basically, absolute converts, so absolute gives the absolute value. So what it does is it removes, absolute value is always a positive number. So if we do, let's say we did 5 minus 7, the answer should be minus 2. But if we've used this pipe formula or we've used the absolute function, instead of having minus 2, we would have just 2. You understand? So it turns everything to positive. That's what absolute does. So the minus in front of it is to remove it, to give us the absolute value, right? So they said we should use this formula to calculate our percentage difference. So we know that the percentage difference for the number. Okay, so let's just move past this one. Let's go back to our data set. So we'll first start with the percentage difference That's the worldwide population. So we'll just do pop underscore percent underscore difference, right? So what would this be? Like our formula told us. Let me just go to our formula bar. It says V2 minus V1. So our okay, let me don't do it under this one. Let's do it under this one here. So is equals to V2. Let's say our V2 is this, right? Anyone can be V2, anyone can be V1. So it's saying V2 minus V1, right? Divided by average of the same V2 and V1, which is C3, comma C2. Then times 100. But this is not yet correct. They told us we are supposed to use absolute. So you can see it here. So we have to use absolute of V2 and V1 so that if this is even giving us negative, it should convert it to positive. So we'll first put that. So in our formula bar, we'll come here, we'll put absolute. So we close the brackets. You have to close the brackets. So this absolute is just affecting this one here, right? And then divided by average of this number here. So we have to also put this one in brackets so that we don't confuse ourselves and we don't confuse the system. So, I mean, calculate the denominator, and then you times it, denominator, and then you times it by 100. That's what it told us to do. So this, we just put one here, and then we click enter. All right. So I hope this is clear. So absolute of these two numbers. So we'll minus these two numbers, and then we divide by the average, and then we times it by 100. That's what the formula says we should do, right? So make sure we put absolute. Now, the absolute is just affecting the numerator. That's the reason why we open bracket and we close it here. Now, the average is just affecting the denominator, so we don't want to confuse it. So we are closing brackets so that it should work on them separately. Work on the numerator separate, work on the denominator, divide it, and then times it by 100. So that's what it has done here. So now we've gotten our population percentage difference. You know, now what to do for urban. So we'll do U underscore pop underscore percent underscore diff. So you see the same formula, but the only thing is we'll be using these two numbers here. That is the number for the urban population in our data set, and then the number for the world population in our data set. So what I'll just do, I'll just copy. I'll Control C, come here. We'll come to our formula bar, and then we'll change the values. So instead of C3 and C2 that is speaking to these ones here, we'll be using C6 and C7. I hope it's clear. C6 and C7. So we'll come here, we'll change this one to C7 and this one to C6. We'll go to the average side too. We'll change the C3 to C7 and then the C2 to C6, then we click on enter. So now we've gotten our urban percentage difference. Well, this is actually funny because initially when we were looking at data sets, the numbers were looking as if they were very, very close. But if you look at the percentage difference now, it's showing us that actually the difference between the world urban and then our, the urban population difference is actually times 2 of our population percentage difference. So it's what it's just trying to tell us that even though like with actual numbers, it's looking close, but once we turn it to percentage, we'll now have to once we turn it to percentage, we get to see, how far apart they really are. All right, so we've done that. Let's go back to our data set. So what does it say we should do? It's telling us now to create a visualization to compare the share of the national population in urban versus the rural area. So let's create a line graph. So they're telling us to create a line graph on our global world and global 2020 reports. And then our independent variable, which is the variable that is not shaking, that we got other variables from. And from our knowledge, we know that the variable that most of those other variables are gotten from is POP_N. So would be on the x-axis. So POP_N will be on the x-axis, while our dependent variable, which is the effect, will be on the y-axis. So our dependent variables are both the urban population and the rural population share. So what this is just trying to say is that because the rural and the urban, they were actually gotten from the POP_N. So urban population percentage and rural population percentage, if you add it together, it should give us 100%. And that 100% would be the actual value of the POP_N in thousands. So that's just trying to explain. So we now said we already have the urban share in percentage in the POP column, but we don't have our rural share. We already have POP_N, we have POP_N and we have POP, but we don't have POP_R. But we want to assume, or we know we can assume that we only have two groups. They can only be urban and rural. There's no other, group in that. So it's not that in this order, the sum of the urban and rural share should be equal to 100% for each of the countries. So we have to create a new feature called POP_R, that is the rural share of the population in percentage using the features POP_U and POP_N. So what they are telling us now is that we'll use POP_U and POP_N to calculate our POP_R. So how do we get our POP_R? We'll come here. So we'll do POP_R. No, but it will be total data set. Total data set POP_R. All right. So we can easily just get this one by minusing this one from this one, right? So let me show you. So we'll just do is equals to our data set population, national population that we did initially, minus the total data set urban population. This is this one here. Should give us our pop R. This is our pop R. But um but it told us to create a new feature in percentage using our pop R. So we'll come here. They told us to create, this is the faster method to doing it, but we want to create a line graph, and they told us to create a new feature, which is the pop underscore R. So how are we going to get our pop underscore R, which is the for the rural? So we get our pop. We get our pop underscore R by minusing 100 from our, by doing 100 minus our pop U. Since we said pop U plus pop R should give us 100%. So it means that to find R, we'd have to minus U from 100. So what we'll do is equals to, we'll use absolute again because we don't want to see any plus or minus sign, right? Or let's don't do that first. I think there's something that speaks about it later on. So is equals to 100 minus our pop R is going to be 100 minus pop U. So 100 minus pop U. So where's our pop U? Then you click enter. And then you do this. It's fused. So we've gotten our pop R, right? Just to look at our data sets to see if there was any issue. No issue. So we've gotten our pop R. So now they told us to create a line graph using our pop U, pop N, and our newly created pop R. And they are saying the pop N would be our x-axis, the pop U and the pop R would be our y-axis. So how do we do? So I highlight all the necessary columns needed. Pop R, pop U, and pop N. And then would insert. That's where we see our graph. Once we click on insert on our menu bar, we click on chart. Now, once you click on chart, Google Sheets would instinctively help you to create a chart. It's creating a column chart for us now. But what we need is not a column chart, we need a line chart. So this is a line chart. So this is what we need. So click it. But our line chart is still not giving us what we, and the reason why it's not giving us is because we have not done what we were told to do. So they said our x-axis should be what? Our x-axis should be pop N, and pop N is in column C. So column C 1 to column C 214. So we click here. So that's our x-axis. Now let's delete all these ones. We remove. And they told us that our R and U will be in the series features. It will be our y-axis. This is it here. So we have to remove this pop N because pop N is already in our x-axis. So I'll remove it. So I've created the line chart. Now let's go back to our data set and see if we're aligning. So they're asking us which insights can we gain from our data visualization. So go back. So this is their chart. So it looks like we're aligning. So to make it look more like theirs, they said rural. They made rural blue. They made urban black. They made rural blue. They made urban black. Okay, so I'll go back to my data set. I'll first change this one to, I double clicked on it. I'll change it to rural. And then this one, I'll double click on it. I'll change it to urban. Now they made our rural blue. It's already in blue. And then they made our urban black. So how do we customize it? How do we customize it? So would, okay. So those stuffs we clicked on initially, they are called legends. So we can edit our legends here, and then we can control the position. It's already in the middle like this. If you want to take it to the right, you can click it to go to the right. If you want to take it up, you can click it to go up. If you want to take it to the left, it will go to the left. Right? But the way it was, they just kept it in auto, and auto is in the middle, which is actually fine. Now, in our legend, you can change the font as well. You don't need that. Then we can change our text color. We also don't need that. So, but that's legend. Now, another thing we need to do is we need to edit our series. Why are we editing our series? So we can change the colors of these things here. So if you come here, see rural is blue. So we can change the blue to a less colored blue, right? We can increase the thickness if you want. You can change it to this if you want, but that's not what is in our data set. It's normal, right? And then that's that. So let's change urban to black like they did for us. So you see that it has changed to black, just so it can look like what we have in our book. So another thing they did was they labeled the y-axis and the x-axis. So this is label here and then label here. So how do we do that? We come to chart here and axis title. So we can put a chart title. So you can see this title text. If someone says something, please you can mute if you are not. All right. So we'll come to the chart title. So now in the chart title, this year we can just write national, national population versus urban and rural share. All right, so we've done that. Now we can change the what's it called, the size. We can change the text color by using black. We can align it. We want it in the middle, not by the side. What else? So I think this is fine. That's for the chart title, the one here. Now let's do for the x-axis title. So what you just do, you just come here, this drop down menu here, you select your horizontal. You select your horizontal. And then you write, let me just be fast here. National population size. The SI unit is in thousand. You can see it's writing down there, and the x-axis, and it's already in the middle, so we don't have to do any other thing. And the text is black. So that's fine that way. So the text is black. Now let's do for the y-axis, which is the vertical axis. So we have population in percentage, share in percentage. So that's the SI units. So we always have to put our SI units. That's the way you properly, label your chart so that person really can make sense out of it. So this is also black. So I think we're good to go. We've been able to successfully create, the data sets here. All right, so what we'll do is we'll just come to this three menu here, these three dots here, and then we'll move to its own sheet. We'll just move it to this sheet here, just so it can be on its own, and it won't disturb our futuristic plan. So this is it. So, but by looking at this thing, what does it tell you? Just by looking at the visualization, what does it tell you? So you can see that majority of our data sets are from this 250,000 downwards. That's where the majority of our data sets are. Then all these points you are seeing here, all these ones you are seeing here, they are literally outliers. They are outliers because they are far from the mean, or they are far from the position where most of the data sets are. You understand? So some countries are extremely large. I want to know which country is this. Okay. It's having 17,000. This one too, 67 in thousands. So some countries are extremely large, 34 in thousands. That's what we can see from the data set. So let's just go back to our projects and continue reading. So they said, we find that our data visualization is not very comprehensible due to some of our pop-end values being much larger than other values. In other words, they are outliers. See, they're actually larger than some countries they're just too much. But most of the other countries are within this range here. You can see, and that's the reason why it's very dark in here. So, in which way can we change our visualization to be more comprehensible without changing the meaning of our data sets or insights? So we want to, make more sense of it, right? Even though we have outliers, we want to make more sense of it so that we can see all these ones that are here. We can't really see much. All we can just see is that majority of data sets are here, but we can't see what are they saying here. So we want to do it in such a way that we can clearly see what is here. And so how can we do that? So they will talk about how to do that below. So they said there are different ways to deal with outliers, right? Now the first way is that we delete the outliers. But if we delete the outliers, the advantage is that we don't have to change anything in our data visualization. So it will just update automatically. But we've lost information of those countries. Those countries we deleted. We cannot make any future analysis from them because we deleted it away from our data sets, which is tampering with our data sets. So that's not a very good idea. The next one is they said we should edit our visualization. So editing our by adding a maximum cutoff value on our x-axis. So meaning that rather than our x-axis reading up onto 1,250,000, we'll just probably just stop here to 250,000. That's where we'll just stop. You get? So, and that way we'll be able to see all these ones clearly, but we won't see all these ones again. So that's also not a very good way. So the other one they now said another way we can do is we can change the units of our x-axis. So rather than it being in thousands, so our visualization is much more comprehensible. So we can change the unit, maybe like increasing it to be in millions or whatnot. So this way we would not lose any data, any value, but our X would not represent the true difference between population size. It will not show the true difference between population size. So what did they say we should use? It now said we should consider option C. So what does option C has to do? So option C is basically changing the unit of our x-axis. So currently, our x-axis, which is pop n, is in thousands. We've said that countless times, right? And then the actual population size, you have to multiply it by 1,000 to get the actual size, right? So they now said, let's create a new feature in our original data set called pop n m. So now this is, which is the national population size rounded up in the nearest million. So emphasis in the nearest million. So that's what they want us to do. So they want us to round it up in the nearest million. So rather than our SIM being 1,000, so we're doing it in million so that we can see all those clustered ones that we did not see before. So we can see them more clearly. So they're now telling us that what will happen. Okay, so let's do that. Let's just go to our data set and create our pop NM. So to the end, pop underscore n, then m. So what would be our NM? So what they want us to do is to convert to million. Our pop n was in 1,000, so we have to convert to million. So how do we convert to million? So converting to million will simply mean that, not to confuse ourselves, we'll first convert to 1,000 and then we'll convert to million. So it's in 1,000 right now. So to convert to actual number, sorry, it's in 1,000 right now. We'll convert to actual number. So to convert to actual number, we'll times it by 1,000, which is the SI unit it is in before. Now that we've gotten the actual number, we'll now divide by a million to get the number in million. So that's what we're doing. So it's equal to pop n is equal to pop n this is our pop n divided by, okay, sorry, times 1,000. This is us converting it to actual number, right? Like we've done before. So, and then we'll now divide it by 1 million, which is 6 zeros. And the reason why we're dividing by 1 million is so that we can change it to, instead of the SI unit to be in thousands, to be in millions. So we times it by 1 million. So that's 6 zeros. 2, 3, 4, 5, 6. And then we'll click enter. But are we there yet? Okay, we've done this now. Are we there yet? They told us to round up. You can see from our data set, they said we should round up to the nearest millions. So, because as we are seeing this does not look like it was rounded up, right? So we have to round up. So to round up, we'll use the round up function, which is round up. So what does round up do? So it rounds up a number to a certain number of decimal points. So how many decimal points do we want? So you can see this is the number here, and then the decimal point. If you want 1 decimal point, if you want 2, if you want 3. Now we don't want any decimal points, so it's 0. So please, you have to always put the number of places you want to put, the number of decimal points you want. In our case here, we want 0. So we'll come here, we'll put comma, and we'll add 0. Then we'll close our brackets. So this, oh, okay, we're supposed to use the round up formula, not the round. Sorry, round up formula, because we're rounding up. So what we're doing, we're converting to 1,000, C2. This is the pop n in 1,000. We convert to actual number, multiply by 1,000, and then we divide by 1 million to get in millions, right? Once we've done that, we'll now round up round up, rounding up so that we don't have any decimal points. Because they told us to round up to the nearest whole number, the nearest million, right? So once we do that, we just click on enter. Okay, so the problem here is that we need another bracket because this first bracket is for this 2 year, right? But this bracket here has not been closed. So we need to do that. And then we click on enter. So now it has rounded this up to 1. And then we'll drag it to the end. So no more decimal points again. I hope you are following.
Yeah.
So click enter. So you can see now that this is 332 million. This is 221 million. This is 60 million. That's the population in this country, 60 million. Population in this country is 11 million. Population here is 2 million. Population here is 1 million because that's rounded everything up to the nearest million. Let's go back to our data set. So we've done that. So they said, what would happen if we just put round? So if we put round rather than round up function in Google Sheets, they're asking us what will happen if it was just round we kept, right? So the thing is, if we had kept just round would either round up or round down. You know, in school they will tell us that if it's above 0.5, we should round up. If it's below 0.5, we should round down. So that's what round function would do. But if we do it that way, it would affect our data site. It's underestimating our data site. And we need it to either be close to our data site or, so that it can show the true picture. We don't want to underestimate our data site. So that's the reason why we are rounding up. So now that we've rounded up, what did they say we should do next? Our data set again. So they said we'll change the x-axis in our previously created line chart to newly created pop-nm. So our x-axis used to be pop-n before. But now I tell you that we should change it to pop-nm. Now, and then next thing they said we are selecting the aggregate option in our chart editor under the x-axis option, and then average as a way to aggregate both series we added previously. Remember to update the x-axis title to the appropriate represent the new to appropriately represent the new feature we are using. So if you just to read it again, so they are saying that we should change our x-axis to our newly created pop-nm, and then we'll use the aggregate function, to add to from the aggregate option, we'll use average. We'll do average of our both series. Now let's see what that means here. So let's see what that means here. So you say we should create another one. But let's don't create another one. You say we should change this one. So to change this one, what we'll do is we'll come to edit. It's still a line graph. But this place here, rather than pop n, it will be pop nm. So how do we get pop nm? Yeah. So you can see this one here. It's saying select data range. Because what we created initially, what we used to create our line graph initially was pop n, pop u, and pop r. Right? We didn't use pop nm. So we can't find pop nm here. So we have to go and look for pop nm. So how do we look for pop nm? Select a data range. So we click on select a data range. So we're supposed to select one column. So which column are we supposed to select? The column for pop nm. So we'll come to our data set here. Our estimate this thing will come here, and then we'll look for the pop nm column, which is here, and then we'll click it. So once we click it, we'll see that that's changed. It's now on this sheet, and then this signifying this icon here is signified as from a different sheet, and then our column CT, which is where our pop nm is, and then we click on OK. So we've changed it to plus pop nm, right? Because the values are, you see that in here the values have changed. That initially we were having 250,000, but no more. It's no longer 250,000. It's now 250, 500, because this is a million. So we have to change this one to a million, but we'll change that one afterwards. So he said we should aggregate. We should click on aggregate. We clicked on aggregate. And then he said we should use average, not sum, average. So click on average. Ooh. So now it's an average. Now that it's an average, we'll change this one. Let's now customize our data set. Let's see. Let's even see. Maybe it's similar to what we're given. Let's see. Okay. So it's quite similar. But he said we decided to use a smooth line for our line chart and then add a point representation of our aggregate data points. So we have to do that one. You see that our own is pointy, it's not smooth, it's not curved. And the reason why it's pointy is because we're using a line chart, but then they used a smoothed. So this is a smooth line chart, the one that is smooth. So you see that it's looking more like it now. And then they now said all our aggregates, this thing, all our aggregates, they want us to show each of those points clearly. So how do we do that? We come to customize, go to series. This is the point here. This is, so showed all the aggregate points, but we need to reduce it. We need to reduce it. It's too big. Let's change it to 2. It's too small. Let's change it to 4. Yes, so this is clear enough. And then we're not done. We need to change this to millions. We need to change this to millions. So how do we change to million? We edit. We did this earlier on. We go to customize. So we go to chart and axis. So we are changing the x-axis, which is the horizontal axis. So instead of thousands as the SI units, we change it to millions. So we've done that. So we've created this one. I think we're done here. We're done here. So they're asking us the question. So why? The question here is, why are we aggregating? Why are we aggregating? Yeah, the reason why we are aggregating is because if we don't aggregate, let's remove the aggregate first. You can see that our chart is still the way it was, right? But once we click aggregate as average, that's gone. So what basically this is doing is more like, sorry, when we go to our data set, we can see that there are plenty 1, 1, 1, 1, 1, 1, 1, 1. You see 1. There are plenty 2, 2, 2, 2. There are plenty 3, 3, 3. There are plenty 5. So rather than we having multiple 1, once we have that multiple 1, it's not like you can't show it on our point. Well, you can show it, but it would. The point of we doing all this now is because we want to make our data set more visible. So the aggregate is adding all of the 1s together in one place. So all the 1s are in one place. So we are not having multiple 1. All the 2s are in one place. So we are not having multiple 2s. All the 3s are in one place. So we are not having multiple 3s. So it has done the average of all the 1s and then kept a point to represent 1. It has done all the average of the 2s, the ones that are 2s. This is our data set here. So all this one like this that you're seeing, it has done the average. When I mean the average, so it's the average of the U percent, the urban percent, and the rural percent. and it has gotten a number. So the number is what is pointing rather than it having to point multiple one. Even the truth it has done that for two. So all the ones that have multiple values that are aggregated, they make it one so that we can see our data sets very, very well. So that's what the aggregate is for. So let's continue. So they said considering that the sum and so they are asking us now, considering that the sum of our urban and the rural share is equal to 100 for each country, is there any other chart we can use? Yes. So in my own opinion, I believe we can also use a stats chart because it shows it will show it in 100%. Since both of them are in 100%, we can use a chart stack chart to show the urban and the rural shares together as 100%. All right. So now we are done. We're done by investigating our data sets by population size, and we've been able to investigate it properly. You can tell that based off of figure, they actually have almost the same figure. But when we do the population percentage difference, we can see that the difference between the two of them in urban is 1%. The difference for these two is less than 0.5%. Right? In our this thing, we can see that there was outlier in our initial graph that we did. And then in this one, you can see that, okay, they are all, aligning towards the 50%. So we've been able to tell much. So let's just go to the next one, which is we have to investigate our data sets. Based on the access by area. So area. So initially we did by population. So now we want to investigate what access to water at different service level looks like for people in specific types of area. So we want to see different service level. What basic, limits, unimproved, and then the surface water service for national, urban, and rural. So we want to check each of all those things and investigate, look at it, and see if there's anything we can, we can detect from it. So yes, so if you want to do that, we'll have to use a measure of central tendency and spread. So these are the two things they want us to do. So what is the tendency and spread of the different water access features? So they want to know how far, how wide is it? They want to know what is the mean, which one of them has the most number, which one of them has the most percentage rather, how far are they from each other? Different countries, national, urban, rural, how far are they from each other? Are they telling the same story? So next thing they want to know how do these measures of water access compare across different types of areas. So we want to know across different types of areas. So let's dive straight down. So what's the first thing we're doing? So we'll calculate the measure of central tendency and spread of the 4 national service level. In our previously created global 2020 report sheet, let's determine the maximum of each of the 4 national water. So we want to determine the maximum of each of it, which is the Watt base N, the Watt lim N, the Watt on N, and then the Watt so N. Right. So we want to determine that. Also, they said we see that our maximum. Oh, okay. So let's do this one first. We should find the maximum here. So how do we find our maximum? We'll come to our global Mhm. So you want to find the what underscore. Let me just copy it from here rather than having to type. So what base n, what lim n, what on it n, and what sor n, control C, control V. Oh, control V. So you want to calculate the maximum, max. I'll bold it. So how do we calculate the max? It's the same thing, equals to symbol, then the max, we type max, and then the formula will come up, we click on it, we go to the place we want to find. What we are looking for is the max of what base n. Then click enter. So we got 100 here. So from here, you can see the formula now. So max is going to the different sheet, a different sheet, which is the estimate on the use of water sheet. Then it's going to column E, which is where what base n is. And then he's looking for the maximum value there. That's what it's doing. So if I do like this, you see that it's giving different numbers. So because when I copied these four things, they are close to each other on the data set. I copied it this way. They're like this. So, and I did not use any absolute symbol to state that going forward, though, if I copy this formula to any other place, it should still reference E and not a different number. So because they are close to each other, because it's close to each other, they are close to each other, and because I picked from here, so if I keep on going to this side, it will move from this column E to F, column F to G, column G to H, column H to I, like that, like that, like that. So it will be working. So this E of E will turn to F of F, G of G. If I drag it, keep dragging it. Once it gets to H here, to keep on going, if I keep dragging it, because they are close to each other. So I hope that is clear. Now that's just a shortcut method. So if you want to do it, you can just go back to is equals to max, and then you come here and then you click on this one, the same way we did for base n initially. So just so we can be fast. So that's why we dragged it that way. Let's go back to our data set. So our data set is now saying that we can see that our maximum for what base n exceeds 100%. Yes, it does exceed 100%. This is 100.00037 is actually more than 100%, which is not possible since 100% access means that every person in the country has access to the service. So we cannot have more than 100%. That's what they are trying to let us know, because we said that is what is trying 100% is trying to say that everybody in that particular country has access to what basic water service. So let's go back to our data sheet and create a new feature called what base n rounded. So what base n rounded, we would only round up to the decimal to which our value exceeds 100%, because we are not rounding any of our other three service level. So we can use the filter or a new column to check that we now have, values below 100%. So what they're just trying to tell us is that they want us to round it to the nearest, no, decimal, whereby we won't have 100.000 whatever. So what we want to see in our maximum value is 100% for what base n. So now they are saying the erroneous data entry are often due to the different ways in which data are collected. And in this case, having a percentage value that exceeds 100% is probably due to value being calculated from different metrics and other values. So now, so we'll be using the round feature now. I told you round up, we'll round it up, but round, we'll either round it up or round it down, depending on if it's more than 5. Let's go to I decided we should create a watts base n rounded. Control Z, X, M, C. We move to the end. A new column, which is our round base n and watts base n rounded. So we're bolding it. All right. So what would we have in our watts base n? So it will be the round of watts, rounding watts base to the nearest number. Now, if you look at this one now, you see that there's 0 here is 100.00000, and then before you now have 37, right? So what we'll be doing, we'll be rounding to the nearest 5 decimal, because once we round to the nearest 5 decimal, it would remove this 3 and just bring all the 000, and obviously 100.00001,000,000 is still 100. So that's what we'll be doing. So we'll come here, we'll say is equal to round and then we'll go to watts base n, and then we'll click on enter. Oh, so this rounded it up to the nearest whole number, but that's not what we want to do. Just so we are in the, because we didn't add any place, let's just put 5 place so that we don't skew the data too much. So we'll round it up to the nearest 5 place. Oh, sorry. Yes, we'll round it up to the nearest 5. Let's just leave it that way. Round it up to the nearest 5 because what we saw here was nearest 5. So we'll drag it down. Hello guys, are we following?
Yeah.
Hope I've not confused us. All right, so now we've rounded it up. We'll now go back to our, instead of using our watts base n, we'll use watts base n rounded, because that's the value we're using, the rounded value. Let me change this to, so this is U. You can see that it's column U, it's on column U. So we'll just come here. Instead of E, we'll change it to U. So that it will reference column U, not column E. I'll click OK. But once we click OK, it's saying, it's giving an error. So it's saying function round. One expects number value, but we are seeing none. And none is a text and cannot be coerced to a number. So basically what it's saying is that in that our rounded up value, we have a non value there, right? And they cannot round up a categorical data. They cannot round up strings. They can only round up numbers, integers, floating numbers. That's the only thing that can be rounded up. So we have to do something about that none, right? So let me just Control C. Okay, so we have to do something about that. Let's see what the data says. So it says, why do we calculate our feature to round rather than using the decimal? So there's a tool called decrease decimal places. Let me show you. Yes, this tool here. So for example, if I come here and I want to decrease, I can just press here and you see that it's decreasing the number, it's decreasing the decimal point. So what they are trying to say is, why didn't we use that one for this one here that we had to go and round up? Let me control Z back so that we have our data complete. Push. So yes, so why did we not do that here? That we had to go and be rounding up, creating a new column and rounding up. So the reason is that when you use that function, it doesn't change the number itself. It just changes, it doesn't changes the number itself. It just changes what you are seeing. Like what we are seeing now, it changes it, it reduces it in our visual. But where those data are being stored in our database is not changing it. So it means whatever calculation we are doing, we are still using the initial calculation. So that's the reason why we are not using the decreased decimal place. I had to check online for that because yeah, so that's the reason why we are using the decrease. Sorry, we're not using the decrease. That's the reason why we had to create a new column, which is the word base n rounded. Let's go back to our sheet and let's see what it says. So it says if you only wanted to round the values that exceeds 100 down to 100, how are we able to use a conditional statement to do that? So they're asking us, can we use a conditional statement? We did a conditional, we are doing conditional statement this week, and I would want to dive into that. Let's just move on. So on the global 2020 report sheet, where we calculated the maximum of each of the water base, we changed the reference to what base n on the function to the newly, so rather than what base n, we're changing it to the newly formed what base n rounded. And when we did that, we see that we get a value error for our maximum function, like we did here. We got a value error. So they're now saying that looking at the typical value in our what base n rounded using the filter, we can see that we have value error in our rounded function. So let's use the filter and change the value entries in the column to a text nan, nan. You know, we've established that nan and blank space are not the same thing. And so they are telling us that anywhere we see value, we should change it to nan. Now our maximum function should work. So let's go back to our data set. So it said we should use filter, and to do filter, we have to come to this place like we did earlier on. We click here, we click on all the sheets, then we click on the filter on the toolbar. So once we click on the filter, you can come here and see all the values we have. You can see blank. Let's see. And we can see value. So they want us to change these values to nan. So let's clear. Let's only see the value. Okay. So how many values? So it's just this two that is disturbing our old data set. So they want us to change this to nan. Let's see what they said and how we can change those two to nan. So they said since we already determined the maximum, since we already determined the maximum since we already determined the maximum value, we know that we don't have any value above or approximately 37% for what lin n, what on lin and what So n. So let's also determine the minimum value. So they want us to determine the minimum value. So we've not changed this none, and they are telling us that we could use our previous conditional statement, which we did not do before, because we will be doing that this week. So rather than that, we'll be using a find and replace. So there's no need to do find and replace. We've been able to filter it. All we just need to do is change this to none. 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 So once we change those two to none, we come to our data sets, we see that we have 100 here. So we'll unfilter back. So all the ones, all the ones that has that value error before, we've been able to filter it out. And it was just two. And those two values, we change it to none. So once we change it to none, now we have our maximum value. So the next thing they want us to do is that we should calculate. Next thing they want us to do is that we should calculate the minimum value for these 4 service levels as well. And then after calculating the minimum value, we have also to calculate the mean. For a normal, we have to calculate the mean, median, mode. And then they now said, let's also calculate this function for the remaining 3. So we're supposed to calculate maximum, mean, median, mode for those 3. And then also we have to now calculate interquartile range and standard deviation for these 4 features to gain more insight into our data sets. So now they are telling us that we should remember that interquartile range cannot be calculated using a single function in Google Sheets. So we need to use a function. We need to use functions to determine the first and third quartile in order to calculate our interquartile range. Our interquartile range is our Q3, which is our third quartile, minus our Q1, which is our first quartile. So let's go back to our spreadsheet. So we have to do mean, mean, that's minimum value. Then actual mean, which is average. Let me just, okay. Mean, average, which is mean average. Median, mode, Q1. Okay, let's do Q3. No, Q1. Q1, Q3. So we're using the Q1 and Q3 to calculate our interquartile. But before that, let me create another space for standard deviation. It told us to calculate standard deviation as well. So standard dev. We are creating standard deviation. Okay, so since it's still the same formula we're using, it's still the same column, we are working our mean. Let me just bold in this one first. So since we are finding the mean of column U in the estimate, this is column U here. So what we'll just do is that we'll just copy, we'll paste here. So, but we'll change this maximum to mean because it's the mean value we are looking for, not the maximum. Enter, we've gotten our value. So same thing, we'll paste. We'll change the maximum to average because it's average we are looking for, not maximum. For that column U, we click enter to give us. So we'll do the remaining for every other one. Let me just do it. change the maximum to median, or is equals to median. Click enter. The next one, mode, change the maximum to mode. Enter. The next one, Control V, change the maximum to standard deviation. So standard deviation is STDEV. Then you click enter. So the other one, the next one is Control V, you paste, you change the maximum to quartile. Quartile. So if you see quartile, you see that it returns the value nearest to a specific quartile of our data set. So you can see that there's 3 here. So this 3 means third quartile. If you put 1, it's first quartile. If you put 2, it's second quartile, right? So since we are doing our Q1, which is our first quartile, so we have to put 1 here. So we'll come here, comma, space, and put 1. So that's indicating our first quartile, and then we click enter. So let's just copy the one for quartile. Control C, Control V. So rather than we change this one to 3 because it's the third quartile. Now you've seen the difference. So this is quartile 1, this is quartile 3, right? And then now the interquartile. So our interquartile is equal to Q3 minus Q1. So this is it. So now let's do the same for this one as well. So I would have said we should drag it like we did earlier on, but we can't drag it again. The reason why we can't drag it is because this particular one, this word is n rounded, is at the end here. So if we drag it, will be picking V, it will be picking like this, like this, like this. We don't want it that way. You understand? So that's the reason why we can't do that shortcut method there. So what we'll do is we'll have to do this one here, and then we'll now use the shortcut method. So how do we do this one? The same way we did it down. So Control C, Control V. So we'll change it to mean. Enter. We change it to average because we are looking for the mean. Please note, the reason why I copied is because we are dealing with what lib n, which is for column F. Here you can see what lib n here is column F. So all I just did, I just copied the first one and I'm pasting it, but I'm just changing the formula to what we want to solve. So what we want to solve here is median. Change it, then mode. Mode, then standard dev. Then Q1. So we'll change it to quartile. Quartile. But you know, we also have to indicate which of the quartile. So it's first quartile. So click OK. So do quartile. Which of the quartile are we doing? The third quartile. So now that we've done the third quartile, so our interquartile, let me just drag it since it's the same formula. So our if you click on it, you see that our interquartile has changed. So initially, yeah, our interquartile was B21 minus B20, which is these two value here. But when I drag it, you see that now it's giving us C21 minus C20. So this is our interquartile. So now we can drag the drag method to do the remaining ones. You can see that this is F, this is G. Look at the formula bar, is G. This is H. So it's working perfectly. So we'll do the same thing for this one too. Fill it quickly. We'll do the same thing here. We fill it quickly. We'll do the same thing here. Do the same thing here. So we can populate all of our data. Then populate this as well. Let's go back to our data set. So what does our data set say? So our data set said that for Watts base n, we see that the mean is relatively high, and then the interquartile range is about 1/10 of the range, which indicates that our data are concentrated around a point closer to the 100 than 0%. So Watts base n. So see our mean, see our interquartile. So what they're trying to tell us now is that majority of our data points is closer to this value. It's closer to the mean, right? Which is the around this 87 to 100 thereabouts than it is to 0 for this Watts base n. So this means that majority of people represented in our data have access to at least basic water supply on the national level. So it's clear. It's clear. So majority of our people in our data set, they have, because like we just said, that majority of them are closer to the mean, closer to the hundreds, you know. See the values, they are on the high side, closer to the hundreds, right? Even the spread is not that much. So what is just trying to tell us now is that majority of the people in our data sets, since Watts base n means people that have basic water supply, so majority of people in our data sets, speaking on the national level, I'm not talking about urban or rural, majority of people in our data set on the national level, they have access to basic water supply. So fewer people now has fewer people in as limited supply, even fewer as unimproved, and the least from what we can see. So on a national level, the surface for all the countries. So now, so this means that majority of our people represented in our data set have access to at least basic water service on a national level. So how can we visualize our measure of central tendency and spread for the different water access future for each of the areas, national, urban, rural, in order to make an easy comparison? We want us to visualize everything in one visualization, right? So they said visualize the 5-number summary. Our 5-number summary would include our minimum, maximum, our first quarter, second quarter, and then our median. So we have to visualize the 5-number summary, right? For the 4 access feature across the different. So now 4 access feature we've done all those, calculations for the national level. Now they're now telling us that we should create a box and whisker diagram, also called a candlestick chart, in our global 20 report sheet from our measure of central tendency and spread summary of all our 12 features. So they are saying 12 features. So it's not just the Watts base n, Watt link n, 100. So So we're going to calculate for the N, we'll calculate for the R, the rural, and then we'll calculate for the urban. So each of these features will represent one instance of a box and whisker plot, which is each of which will be represented on the x-axis. So they're saying all of this will be represented on the x-axis. So we would interpret each of the candlesticks value in the following way. They are saying the low and high. The low and high are our minimum and maximum. So our low will be our minimum, and then our high will be our maximum. That's when we are representing it in the visual in our chart. And then our open and close will be our first and third quartile. Remember that, okay, so let's just go to our chart and populate for the remaining. We stopped at what surface N. So let's go. So we'll copy the same way we did earlier on. So what base R, what in R, we copy for R, then we'll copy for U. Control C, that's it. So we'll do it here. Right. So because we'll still drag it the way we dragged it earlier on, because they are aligning. So you see that the value here is 30, the value here is 100. And if you look at the formula bar, you see that this is H and this is I. And if you go back to our main charts, you see that I, the column I, stands for what base R. So you see that it's aligning, so it can be very fast. So we just copy it to the end. We do the same. We do the same. Do the same. We drag it to the end. Drag it to the end. Yes. So we've been able to populate everything, right? So they told us to create a chart. The chart they told us to create is the box and whisker, which is also equals to candlestick chart. So would highlight everything. We'll go to insert, the same way we created chart earlier on. We click on chart. We'll come to the chart type, change it to box and whisker. See, or candlestick, see candlestick chart. So we'll click on it. So this is our candlestick chart. So, but they told us to do other things. They said all these values here would be on our x-axis, right? All those values here will be on our x-axis, while our minimum would be our low, our maximum will be our high, our open will be our first, and then our close will be our third quartile. So we have to do that on our box and whisker chart. So we'll come here. So we have to, they said our low. So they said our low would be our minimum. So we have to click here, data range, like we did earlier on, and look for our minimum. So this is our minimum here, 15. Row 15 is our minimum. So click on OK. Okay, so the reason why it's not working is because we need to switch rows to column first, because our low is only taking column. So we need to let the system know that we're switching rows to column. So now that we've switched rows to column, we can easily just come here and then change our low to minimum, our open to Q1, our close to Q3, and then our high to maximum. So we've been able to create our box and whisker chart. So let's see if it looks like what we're given in the chart. So you see, it looks exactly like it. So what we need to do next is now to label it. But I already showed us how to label earlier on. So we won't waste time on that. We'll just, move it to its own sheet. So we've moved it to its own sheet. So just by looking at this now, you can tell yourself something. Look, click on this. You can see that this is the national. What is national? So it means that majority of people of countries has access to basic water supply, right? On the national level. Now see the limited, the unimproved, and the surface. See how low they are, right? Now see for the rural, you can see that majority, because the Q1 and the Q3, basically the interquartile is simply like when most of the data are. So most of the data of this, meaning that most of the countries in rural are between 64 to 99. So most of them, they have access as well to good water supply when compared to the limited access and unimproved. They have access to basic water supply when compared to the limited and unimproved, then the surface, right? So you can see that many of, but for the urban, you see that the percentage of urban, you can see that the percentage of urban is actually smaller than the rural, and it's closer to 100. You understand? As expected, rural, as expected, because it's rural, some people would have, close to 100, while some rurals would, they will share it with all these other ones. So, like you can see, the rural also has the highest unimproved, and it has the highest surface and the limited when you compare it to the urban or compared to the national. So the urban has the least. So as expected, urban should have, should be closer to 100. Most of the urban cities should have access to basic water supply as expected compared to the national and then compared to rural. And you can see that urban does not even have surface water. So majority of the urban, none of the urban. Let me even see what's the value. So just a very small percentage of the urban still goes to take water from well or ocean or river. So majority of them have good water supply. They have access to basic water supply, and that's why most of the data are closer to 100, right? So we can tell something from that. So let's just go back to our charts. So based on what can we say about the distribution? So like we said earlier on, so we've been able to talk about access by area. We've created a box and whisker chart that we can clearly see the access to water based off of, the national basic, national limited, national unimproved, and national surface. Then we can see for rural as well, and then we can see for urban as well. So let's go back to our project. So in our project, the next thing we are doing, we're investigating access by population size. So we want to investigate what access to water at different service level looks like for different population size. So now, initially we did it per area. The one we did before was per area. Now we want to do per population size. So what does the national access to water look like based on the national population size? Right? So we want to compare the access to population size. So what does the urban access also look like based on the urban population size? And then what does the rural access looks like based on the rural population size? So we'll come down. What did they say we should do? So they said we should visualize the national access to water on all 4 levels based on the national population size. So in our previously created Global 2020 report sheet, let's create a bar chart. So now we have to create a bar chart. Since we want to investigate how population size affects access levels, population size per N. So so we want to know how population size affects access levels. So we want to know if the country is a large country, does it affect or does it the country being a large country, does it affect the water access they have? So are we saying countries with larger population would have access to basic water, and countries with low population would have more access to surface water? Or are we saying the other way around, that okay, countries that are small, they will have access to they have more access to basic water compared to countries that are large? So that's what they're trying to. So now they're saying our independent variable will still be our pop n, and then our 4 access features, which would be our dependent variable, which is our y-axis, would be our watt base n, watt lib n, and watt surface n. So because of our access level, our percentage, and we know that an individual or household can only be at one of those levels. So yes. So basically, what they are trying to refer to is that what base n, what lim n, what on in n, and what surface n. The 4 of them should give us 100%, because each people in each population, or each households in the population in the country, would either belong to one of these, right? The total of everything cannot pass 100 or be less than 100. So we can use our 100%. So we can use our 100% stacked column chart to visualize it. All right, so let's continue. So as in our investigation on population size previously, we observed that using the original population size in hundreds is relatively unintuitive, because the bars are too narrow and we have too many of them. So what do they want us to do? So they said, remember, each bar now represents a single country. Okay, so let's just go back and create our 100% star chart using these 5 things, which is the population n as the x-axis, and then the water service for national, which is water basic, limited, unimproved, and surface as our y-axis. So we'll come here, we'll go back to our data set. So we're using pop n, we hold on to control, and then we're using surface n. Oh no, let me restart it. So pop n, click here, what base n, what lim n, what on it, and then water surface national. So we'll go to our data, we'll go to insert, and then chart. So they told us to use the 100% stacked column chart. So look for it. So this is the 100% stacked column chart. So click on it. So now that we've done that, we said what would be our x-axis. They told us our x-axis would be pop n. Why not clicking? Let me remove it from here. Okay. So let's fill our series first. So our series has already been filled. What's base n? What's min n? What not unimproved n? So let's come here. Let's say language. Let's see. Okay. Okay. So um let me add another range. Let's see what's going on. Let me delete chat and start it again. So put this, 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 and then we go to insert chart. Okay. So our x-axis now is our pop n. Then we remove pop n here. So we've created our, so let's now what's the word, make it look like our chart, right? You can see that a lot of data are here. Like let's move it to a different sheet first so that we can see it more clearly. So this is the different sheet. You can see a whole lot of data are here. Sorry, pardon me, give me a few seconds, I'm coming. Sorry guys, I'm back. All right, so we've been able to, let's just make it look a little bit like how we have in our chat. So we can see that the surface is red, unimproved is yellow, limited is green, and then blue is for basic. So let's come here. The same way we customize our series. So basic is blue and it's already blue. Maybe we should just change it to the fill color. Maybe we can change it to a less thick blue. So this is too light. So then we can also do limited is green. So we can change it to green. Limited is green. Unimproved is yellow. So let's just do that. And then The surface is red. Yes, so now it's looking much more like our data set. But like we rightfully saw in the first line chart we created, because we had so many data clustered down, we could not clearly see, though, even though right now we can see that everywhere is blue. And what blue is indicating is most people have basic access, but we need to be able to point at one of these things and say, okay, this is the value for basic, this is the value for limited, this is value for only. But it's too clustered together, so we need to, make it bigger. So that's what the next one is going to do for us. Let's just go back to our data set. So what are we doing now? So now that we visualize for national, they want us to do the same thing for urban. So it will be the urban population and then the percentage of the urban water access. So rather than using pop n and watt base n, watt lim n, one of unimproved n, and watt surface n, we'll be using pop u and then watt pop u. Watt basic u, watt limited u, watt unimproved u, and watt surface u. So you can see what it says. So let's use the population share watt u in percentage as our independent variable. Now, in order to avoid a messy bar chart, we are going to create a new feature called a pop u rounded so that we don't have a messy bar chart. Remember how we did for that line graph earlier on, that we had to create this one, that we have to create a rounded, and then we have to aggregate it so that we can see the data more clearly. So I think that's what they want us to do here. Sorry. So that's what they want us to do here. So they are saying that we create a pop u rounded and we round it to the nearest whole number. And then we'll use this new feature as the x-axis in our 100% stacked column chart. And then set the aggregate to average. So this is the same thing as what we did earlier on. So we notice that our x-axis isn't arranged from 0 to 100 as expected. So let's order our data sets based on pop u rounded before we consider any insights. Okay, so let's do that. So we'll use pop u rounded to create our next 100% column chart. Let's go to our data set. So we'll look for pop u. We'll create a pop u rounded. Pop u. Okay. Pop u rounded. Create a pop u rounded column. Oh, sorry. Control C. So we're bolding it. So we remember how we rounded initially. So we'll round to the nearest 0 decimal. Like we're rounding up to the nearest whole number. So basically we'll be using the round formula to round up to the nearest whole number. So is equals to round. For me, I like to still put 0 just to let it know that it's 0 decimal point. But regardless, it will still do the same thing you want it to do. So round, once you click on round, then you round pop u. So you are rounding pop u to the nearest whole number. So this is pop u. Sorry. Let me just be sure. So it says, in order to avoid a messy chart, we are going to calculate a new feature called pop u rounded, which is the urban population share POPU rounded to the nearest whole number. Use this new, okay, so that's what we're doing. So we
Right,
do
Mr.
this,
Lat, well
yes,
done.
thank you.
Sorry, I have to go now. I have a family prayer and I need to attend.
All right, the recording will be shared.
So that I can catch up
Yes, the recording will be shared.
on the platform, right?
Yes, on the platforms. Or you all can also message me so that I can send it to you guys personally. Thank you.
Thank you.
So, comma, and then we're rounding up to the nearest zero decimal point, and then we click on enter. So, once we've done that, we'll drag it downwards. Sorry. All right. So, we've been able to do our POPU rounded. So, now we'll use it to create a chart. So, POPU rounded, what's base U, what's lim U, what's unimproved U, and what's surface U. So we'll use it to create our 100% column chart for urban. So we can see the distribution in percentage. So 100% stacked column chart. And then our x-axis would be our POPU rounded. Our x-axis will be a POPU rounded. How does this thing do this? All right, so no cause for alarm. Let's just delete everything and put it one by one. So our first, this will be second one will be third one will be a C. POPU rounded. So what base U, what lim U, what unimproved U. Then we add another series, which is the what surface U. So what do they want us to do again? I think they told us to aggregate and set it to average. So go back to our data set, aggregate, set it to average. So you see that this particular data chart is much more clearer. Is much more clearer than the initial one. See that there are so many data points in this one. For this one now, we've rounded it up, then we've aggregated it by average. So we can easily see and make more sense out of our data. So let's just move it to a new sheet. This is our fourth chart. So let's edit it for, customize it just so we can give it that initial feel. So change the series color. Limited will give us green. Unimproved is yellow. Let's just give it a light yellow. as too light. And then the surface is red. So we can easily see all these things distinctively. So we can come here now and say, okay, unlike before that we can't click and make sense. We can come here and say, okay, this particular, I mean, countries that have, countries that their population is about 56, or there are countries um that has 56 percentage. In that 56 percentage, we can say that 95% of it. So this is the population, sorry. So country that has the population of 56, countries that has the population of 56, we can say that this particular one has, basic, 95% of it is basic. And then the remaining 3.3 is limited. And then a very small portion, which is 1.1, is unimproved. We don't even have surface in this one. We can say that this particular one here is literally is 99.9. We can say that there are countries that have 100%, like this one now, that have 100% basic urban water access, right? So you can make more sense out of it now. And that's the reason why we had to round up and aggregate. So now that we are done with that one, let's see what they told us to do again. So they're saying consider how our national bar chart now has an unordered x-axis. Why is that? And how can we change our data set of visualization so that all of our bar charts are always in the correct order? So let me see. So you can easily see that in this one now, there's 0 here, there's 56 here, there's 9 here, there's 90 here. This is not order. This is not moving in ascending or descending. So we need to change it. Let's see this other one. So how do we change it? This is in ascending. So how do we change it? So it means we have to go to our pop rounded here, and then we'll sort by from A to Z. We can see now is in ascending order. And once we've done that, you can see that now our chart is much more clearer. So you can see 100 here, 100, 100, 100, 100, 100, 100. So we can easily see this one is now. All right. Let's move back to our chart. What did we say we should do? We said we should also visualize the rural access on all 4 levels based on the rural population. In our previous created global 2020 report sheet, let's create another 100% stacked column chart, similar to what we created in B, but only for rural access. Let's use the rural population share as our independent variable. So our rural population share will be our independent variable, the same way we did for urban population share. So we are going to create a new feature of R rounded to the same way, which is the population share of R rounded to the nearest whole number. And then we'll use our new feature as the x-axis in our column chart. So let's go back to our chart. And then we create R rounded. So what we in our R rounded is equal to is our R. This is our R. And then 0 decimal place. Then we'll close our bracket. Okay, so we'll wait for this plus sign and then we'll drag it to the end. But this is also like this. It's going to give us a chart that is not in order. So we have to sort also. Let's see if we sort it to affect the other one. It is affecting. It's almost like inverse. Let's control Z back. All right. So this is what will happen. So we'll create a chart like they told us to do. It's 100% stacked column chart for pop R rounded. I'll load in my control. So I'll take water basic R, water limit R, water unimproved R, and water surface R. Then I'll go to my insert in my menu bar, and then I'll click on charts. So the same process by using an 100% column stacked chart. What would be our x-axis? Our pop R rounded. I stressing me again. So pop R rounded. Click here. Yeah, 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 yeah. So let me just come here, delete all these ranges here, and do the ranges myself from the start. It is not so W of W. We'll add the next one, which is um column I, and then column J, column K, and then column L, column N, L. Okay, so you click on OK. So you see that once we did that, it has changed. So you see that this is our pop R is now in our x-axis. Our what base R, what limb R, what on him. So everything is complete now. So we can just move it to a new sheet. So we can just edit just so the colors are aligning. We go to our series. So we change the colors one by one. For basic is blue. For limited is green. Unimproved is yellow. And surface is red. Okay. So what did the project tell us to do now? So the project is saying comparing the 100% stacked column chart for national, urban, and rural. What can we say about the access? Is it related to population size or area share? So let's go back to our data sets. Obviously, unlike the urban population size we saw earlier on, that we saw everything all blue. So it means for urban, they have good access to basic water, all blue. You can see that for rural, is a mixture. You can still see a lot of yellow, see a lot of red, see a lot of green. So there's still plenty blue, but I mean, if you look at all these places, you see they have larger portions of, for example, now take this one for instance, the urban water basic rural has 51%, and then 11% of it they use limited access in the rural, 12% of it unimproved, and about 24% they make use of surface. Take this one for example now, you can see that 34%. But when you are looking at the urban 100% star column charts, I don't think I've ever seen any one that is getting up to like 20%. This is the highest you probably see. Every other thing is blue. So what we can say is that the urban area, they've been consistently performing the best. So like you said, based on urban, they usually have basic access to water. And then the rural area has performed the worst. I mean, when you compare this one with this one, you can see that with the national, you can see that the rural is actually more colorful than the national. So just to you can now say that okay, the access to water is more strongly related to area type. I mean, when you compare the charts we did before in terms of population, and then the charts we did before in terms of still on population, right? And then you compare it with our box and whisker chart, and then you compare it with our 100% column chart, you'd see clearly that it seems that based off of rural and urban, it shows this one is showing more, it's giving us more information, like we can easily visualize and see more things, rather than when we're looking at it based on population size. All right. So we've been able to do that. So let's continue looking at what was given to us. So now they said the next thing we are doing now, we're investigating by income group. So we investigated by size, we've investigated by basic this, that, by water access. What we just did finish, we were investigating by area. So we want to know if urban area or rural area, which is the one that's given us the most, visualization that we can really interpret. Now we are doing investigating assets based on income group. So we want to investigate the relationship between the gross national income of the country, right? Or income group population size, urbanization, and national water access. So economies are classified into 4 income groups based on gross national income, GNI per capita. So what do we want to know? We want to know what is the effect of the national population size and urbanization on our gross national income and water access. So what did he say we should do? He said we should summarize the data sets to groups and investigate by 4 national income. So in our previously created global 2020 report sheet, let's create a pivot table. So we are creating a pivot table. Let's create a pivot table because we want to group by income group. So we will set our rows to be our income group, and then our values are the sum of the population size pop n. So sum of pop n, the average urban size pop p, and then the average national basic share of limited unimproved surface area access. So these ones will be so they will be our values. So let's also visualize our summary data in order to better investigate the link between. So we're trying to investigate the link between income group. You know, that's what we're setting it. Our income group is our role and other features. So we are doing income group with our population size, income group with average urbanization, right? With urbanization, like they said, and then with water access. So average water access. So now, so income group more appropriately. So let's convert our text column to income group in the data set sheet to numbers. Okay, let's first do what they told us to do. So we'll go to our global 2020 report. Global 2020 report. So he said we should create a pivot. So how do we create a pivot table? So we click on the spot here, come to insert pivot table. So it's asking for data range. What's going on? Okay, insert pivot table. So it's asking for data range. So what would be our data range? Our data range would be our old data. So we come here to come to, instead of even going too far, it has given us, this is our estimated on use of water complete. So from A1 to W21, no, 214. So if you do 214, it will be including, let's see, it will be including all the ones you just created now. So we can't do W214. We'll stop at, so we need pop n, we need pop u. Let's see. We don't need pop r. So let's just, actually it doesn't even really mean when you think about it. Since what we are looking for would look for that one precisely. Let's just click here and then okay. So it's asking us for a new data. Should we insert it in a new data sheet or an existing data sheet? Because we want to put it here. So we'll put it in our existing data sheet. So we'll just create. So it's asking us for destination. This is our location here. Create. All right. Now that we've created, so we have to change our role. So we said our role would be income group. So role is our income group. And then what will be our value? So our value, which will be sum of pop n, will be sum of pop n, would add another value. The other value will be average of pop p. So this is sum, so we change it to average. Average of pop p will include another value again. So the other value is the average of water basic n, average. Another value in n, average. Another value, what on in n, average. And then the final one, surface n, will take it to average as well. So we've been able to So we've been able to do the task given to us. All right. So the next thing they told us to do is that we should let's convert the text column income group in the data sheet to numbers. So where N is 0, low is 1, low middle income is 2, and then upper middle income is 3, high middle income is 4. So you can use any visualization method and any method to convert. So you can use any visualization and any method to convert the text income group to numbers, including creating new column or finding and replace. So we will use the find and replace value. So what we'll do is find and replace. So we're done with this one. We'll just remove this one, and then we'll do find and replace. So how do we get to our find and replace? So our find and replace is in the edit on the menu bar. So this is find and replace here. So what are we finding? So they told us to change. Let's start from the one they told us to change first. They told us to change NaN to 0. So we change our NaN. So they have to find NaN and then they'll replace it with 0. So we replace all. So the next one, they told us to replace low income to 1. Replace all. They told us to replace lower middle income to 2. Ooh, Control Z. All right. So find and replace again. Go back to the edit. Go to find. Control C. Control V. Change it to 2. Replace all. And then upper middle income. Control C. Change it to 3. Replace all. And then the final one, which is high income. So we'll change it to 4. So the reason why they are doing this is just so, and then we're done. So the reason why they are doing this majorly, the reason why this is being done majorly is so that we can, we can easily see the progression. So is ordering, like is putting everything in order. So for example, if you want to create a chart now, we would easily see it 0, 1, 2, 3, 4, like that, and they will be in order. It won't be, and then you can easily create a trend and say maybe like, okay, from 0 being the poorest and 4 being the richest. So we are moving from poorest to richest, that kind of stuff. So there are different charts you can use. You can create a clustered column chart, or we can create a side. You can create a side by side chart for this. Um, so yes, let's see what else they want us to do. So we've been able to do what they told us to do. So we've completed the task. If you are still with me, say a. Thank you. You've done well. All right. So that's the end basically. So now we'll now use, so this is just a summary. We don't need to go through the summary again. These are the things they expect us to have created. Now we should, other than 16 features, we should have about 23 features now because we've created new stuffs, right? So this is just some. So let's just move to the MCQ straight. This is the MCQ. So we would use what we've created so far to answer the MCQ. Right? So we'll use what we've created so far to answer the MCQ. Now, for the first question, it said, what is the percentage difference between the data set and the estimated world urban population size? So what is the percentage difference between the data set and the estimated world urban population size? So world urban population size is the total number of people living in urban area for 2020. So we want to know, we'll go back to our data set. We've created something like this before when we did our world population difference. So they're asking what is the population difference between the data set, the population of our data set, and then the world population, right? So, but then it said urban, so it's not world population, so it's urban. So what is the difference between our total data set population and then the world urban population? So this is the population percentage difference. So the answer is 1.7, right? So if you guys were still on your this thing, you see 1.7%. So that's the answer for that one. You know what they ask again? What is the percentage difference between the data set and then the estimated world urban population size? Urban population size percentage difference. And that's what we have here. Population percentage difference. Sorry, population urban population percentage difference 1.7. To the next question, true or false? Based on the national population versus urban and rural shared visualization, where the x-axis is the aggregated national population size. So they're saying the x-axis is the aggregated national population size, and then the y-axis is the population share in percentage. The average population share across all population size are approximately 50 because the chart line fluctuates equally above and below the 50% line. So again, is that true or false? Based on the national population versus urban and rural shared visualization. So two things, the chart they want us to look for is one that has national population versus urban and rural, right? And I think we did a line graph for this. And said where the x-axis is the aggregated national size. So it's aggregated, they want us to look at. Let's go back to our chart. So this is the one that we did aggregated. So this is what they want us to look at. National population versus urban and rural share. So it's now saying that the average population share across all population sizes are approximately 50% because the chart line fluctuates equally above and below the 50 line. So yes, as you can see, this is the 50 line. We can see that it's almost looking equal up and down. So yes, that statement is a true statement. So it fluctuates above the 50%. So the next one, true or false? The distribution of the national basic service feature, which is the what base N, is more similar to the distribution of the urban basic feature than it is similar to the national limited feature. And we talked about distribution earlier on. And when we talk about distribution, we're talking about this, the 5 summary. We're talking about box plots. So we'll come here, the distribution. So this shows us how spread apart each of the data sets are. So what they are now telling us is that they're asking us a true or false question. They're saying the watt base n is more similar to watt base u than it is to watt limited lim n. So let's see. Watt base n, this is watt base n, and then this is watt base u. They are more similar to watt limit n. Obviously, these two are more similar to this one here. These two are more similar to this one here. So the answer is true as well. Now, what is the interquartile range of watt surface R? Let's go to what we created, our 2020 reports. The interquartile range, watt surface R. So this is watt surface R. So the answer is 4.18. Watt surface R. So the answer is 4.18. All right. The next one. So they are saying which of the following country or which of the following statements are true based on the created 100% stacked column chart. So we are looking at 100% stacked column chart for urban population share. So urban population share. This is for national, and then this is for urban. Okay, so they said 100% stacked share for urban population share access and versus access to various water levels. So countries with greater population share are more likely to provide. So countries with greater urban population share are more likely to provide basic water service than countries with smaller population share. Let's look at it. So which country has smaller population share? 0, 9. All these ones, they have smaller population. But this one, they have 100. So that statement is a true statement. As you can see, these countries have more population. So, and you can see that they are literally almost 100%. This is 100%, this is 100%. Okay, this is 100%, this is 100%. Yes, this is 99%. So, and they have, the population is much more plentier than all these ones here. And you can see all these ones here that have lower population. There is majorly mixture between basic access, limited access, and then unlimited access. So without even going further, this is the answer. So, but let's just look at the countries with smaller urban population share are more likely to provide basic. No, it's countries with greater population share that are more likely to provide basic, which we've said countless times. That urban population, no, it's synonymous with basic water. So they said what basic, limited, unimproved, and surface level assets do not increase or decrease based on the share of urban population. This is a wrong statement too. Same thing with this. So yes, this question is the answer for number 5. Countries with greater urban population shares are more likely to provide basic water services than countries with smaller urban population share. All right. So the 6th question, it said true or false. Based on the created 100% stacked column charts for rural population share versus, so we are looking at rural population share now, versus the various water level, there are countries with approximately 100% access to. So what this is now asking us is that in our rural stacked column chart that we created, there are countries that, even though they are rural, they still have 100% access to basic service level across their distance. So let's go and check for rural. So this is rural. So they are saying if there are countries with 100%, I think I can see one here. This is, even though it's in the rural, but they still have 100% basic access to water. I'd love to know this country. Same thing here too. They still have 100%. This one too has 100%, 100%. So yeah, that's a true statement. So number 6 is a true statement. Now number 7. So they are saying now we're going to the pivot chart. So they are saying based on the pivot chart created, what is the national average percentage? What is the national average percentage of access to limited service for low income? So we want to know the average percentage for what will earn for low income country. And low income country is 1. Let's go to our global 2020 pivot chart. Global 2020 pivot chart. So we're looking at what we earn. This is what we earn. So what are they asking us? They're asking us, based on the pivot chart created, what is the national average percentage of what we earn for low income country? So this is low income country, which is 1. What we earn is this. So the answer is 16.55. Oh, what have I done? Control Z. So the answer is 16.55. All right. So let's go down. Let's continue. So number 8 is saying which of the following statements are true for population sizes and shares across the different income group according to data sets. So they're saying which of the following statements are true for population sizes and shares across the different income group. They're asking us questions. So they're saying more people included in these data sets live in low income. So this more people means population of the nation. They're saying more people live in low income country than any other type of economy. So let's see. So low income country is 1, and this is population. Population of low income countries 590k, 590,000. But let's look at other ones. Do we have anyone that is more? Because they are saying this one has the highest number. So let's see. This one that I'm seeing beneath it is 3 million. So that's the first statement. That's the first statement. So for this first one here is false. Let's see the next one. It said high income country are on average more urbanized than lower middle and upper middle. So more urbanized. So we're looking at for you urban, and high income country is 4, right? So 79. They are saying they are more urbanized on average. So on average, he actually has the highest number, which is 79. So this is a true statement. Because if you look at the remaining, it's not up to 79. So that's the true statement. So the next one says more people included in the data set live, so this is population again, lives in the lower middle income countries than in any other type of economy. So what they are saying is lower income countries should have more population than every other one. And what did we say lower income country is? We changed it to lower middle income, right? Lower middle income, yes. So lower middle income is 2. So based on population, so this is 3 million. This one is not up to million. This one is not up to million. This one is up to million, but it's 2 million. This one is up to million also, but it's 1 million. So yes, that's the true statement. So lower middle income, they have the highest population. Now the next question is on average, the greater the GNI, the more urbanization. So they are saying the greater, so urbanization. So they're saying the greater the GNI, which is the gross national. So they are saying that higher income are to be more urbanized than lower income. So let's test that statement. So yeah, that seems to be true because you can see this is the highest of the average for urban, and then the one that follows it next is this one here. Even though 0 is more than these 2, but at least we can tell that you know the statement is true. So it looks like the more money you earn, the more urban, as expected, the more urban you are. So that's a true statement. So the answer, the answer for this would be B, C, and D. A is the first statement. So number nine. So number nine says, which of the following option has the highest national percentage for each of the service level for the different income groups in the pivot table? So now we are going to pivot table. Okay, we were in pivot table before, actually. So they're saying which of the following option has the highest national percentage for each of the service level. Let's look at the service level. So it's saying basic access in high income country, basic access in high income country, limited access in low income country. So which of the following option has the highest national percentage, the national percentage for each of the service level group? So they are saying basic access in high income country. Let's see. Basic access. So which one has the highest? High income country. Okay, that's a true statement. Basic access in high income country, yes. Limited access in low income country. Let's see. Limited access. Which one has? Okay, one is low income country. That's the true statement. This is 16 year. Okay. Unimproved access in low income country. So let's go to unimproved access. This is unimproved access. This is also low. 15 is more than 7. So yes, that's also true. And then they said surface access in low income country. Surface access. This is surface access. Which one has the highest? Still low income country. So this is a true statement. So without even going further, this first one is the correct answer. All right, let's go to the final question. He said, true or false, visualizing the pivot table values for national access versus the income group indicates that that as urbanization increases, so does the share of the population with basic water and the GNI increases. Limited, unimproved, and surface water decreases. Again, so they said visualizing the pivot table values for national access versus the income group. So we're looking at national access and income group indicates that as urbanization increases, so does the share of population and as well as the GNI increases, while the limited and unimproved and the surface water decreases, access decreases. That's the true statement. We've said it countless times. So as population increases, rates. So visualization for the national access versus the income group indicates that as urbanization increases, So let's say urbanization. So this is urbanization. As urbanization increases, this is the highest. Okay, so does the water basic increases? Yes. And then this one decreases? Yes. So you can see that this one is the lowest, is one of the lowest. This one is the lowest, this one is the lowest. So it's actually decreasing, while this one is actually increasing. So you can see that for what's it called? For upper middle income, which is the second, he has the second highest basic access to water, and then the second lowest, or sorry, the third lowest, so lowest limited access to water, and then the second lowest unimproved access to water, and then the second lowest surface to water. So yes, the last statement is a true statement. So as urbanization is increasing, so does the population for water access, basic water access to be precise. is also increasing, and then the obviously the GNI is increasing, and then the limited, the unimproved and surface water access is decreasing. So guys, I think we've been able to cover everything. If you are still with me, say hi. I know it was a very long class session. If you are still with me, say hi.
Hi, Chief. Hi. I'm with you.
Thank you.
Yeah.
All right. I really appreciate everyone for being here and for waiting to the end. Um, so we'll be wrapping up soon. But before we do, um, what I want to say is that just follow the process. Just keep on like looking at the materials and then following through one by one. If you have issues, you can reach out to people. Victoria, sorry, I'm coming out. So just take it a little step at a time. If you have any issue, you can always reach out to me. Um, and if I understand it, I'll let you know. And if you don't, we'll both figure out, how to resolve it together. So let's just put our head in the game and let's don't give up. I want to see everybody in the finish line. And also, um, next week Wednesday, I'll be doing the session for the part two of this integrated project. So please do well to join as well if you have any issues also. So please, Victoria, please go ahead.
Oh, Ola, thank you so much. Oh, I really appreciate.
You're welcome. I
Please,
can't hear
is there
you. Your
any way we
network.
can get your recordings? Thank you.
Yes. I would do that. I'll share the recording. So I need everyone to just reach out to me.
Please, how can we know your handle? Were you the one that post the link?
Yes, I was the one that posted the link.
Okay, thank
Yes.
you.
So I'll still post it to the group chat, but you can as well reach out to me.
Okay.
Yeah, because no problem. So yeah, that will be all. Thank you all for, waiting to the end. Thank you all for showing. Thank you all for engaging and learning with me today. Have a wonderful night. See you
Thank
on
you very
Wednesday.
much. Thank you very much. You really did well. I think prior to now, I tried following up myself. I think I got it to some part. Then everything started, since the audience they just started going left and right. But at least the way you broke it down this evening, I will just sit with it again, and I believe when I look at it, I should have lesser problems. But definitely I will reach out to you. But I have to give you big kudos. You've done so well.
Thank
Thank
you.
you.
Thank you very much. Thank you. All right, guys. Good night. See you next week.
Good night. Thank you.